Right now, inside a secured hangar at Edwards Air Force Base, a fighter jet is being reborn. Not rebuilt, not patched, reborn. Engineers are stripping out systems that were cutting edge in 2005 and replacing them with technology so advanced it was originally designed for aircraft that don't even exist yet. We're talking next-generation capabilities being integrated onto the world's most feared fifth-generation fighter. $7.8 billion. That's what the Pentagon is pouring into 185 jets that already make enemy air forces sweat. And when this modernization program is complete, the upgraded F-22 won't just be the best fighter jet on the planet, it'll be in a category entirely its own. I'm going to break down exactly what's changing, what it means in a real fight, and why China and Russia should be paying very close attention. Welcome to Dogfight Docs. Here's the honest reality. The F-22 Raptor entered service in 2005. That's over 20 years ago. The original avionics, the sensor architecture, the communication systems, they were revolutionary then. Today, they're showing their age. Meanwhile, China has over 200 J-20 Mighty Dragon stealth fighters operational, with more rolling off production lines every month. Russia keeps quietly upgrading the Su-57. Both nations have studied American air power for 2 decades and built their latest systems specifically to counter the F-22's original advantages. The Air Force had a choice. Wait until the 2030s for the next generation air dominance fighter and hope nothing goes wrong in that gap. Or take the most capable air superiority platform ever built and make it even more dangerous right now. They chose the latter, and the 5 upgrades they've committed to are going to change everything. Fact 1. The Raptor is getting eyes that never blink. The centerpiece of this entire modernization program is passive infrared tracking, a technology currently under active development for integration across the F-22 fleet. In January 2025, Lockheed Martin received a $270 million contract to develop and integrate these passive infrared systems onto the Raptor. Here's why that number is justified. Traditional radar is brilliant, but it has a fundamental problem. The moment you turn it on, you announce yourself. You are essentially shining a flashlight in a dark room and telling everyone exactly where you are. Modern adversaries have invested heavily in radar warning receivers precisely because of this. They hear your radar, they know you're there, and they start planning. Passive infrared tracking changes that equation entirely. Rather than emitting signals that can be detected and traced, the system reads the heat signatures of threats in the surrounding airspace. Without broadcasting a single signal, you're not sending anything out. You're just watching, silently. What does that mean in practice? An adversary launches a long-range missile from beyond visual range. With legacy warning systems, the F-22 pilot receives an alert only when that missile seeker activates. That's late. A passive infrared system detects the thermal signature of the launch itself, earlier in the timeline, giving the pilot additional seconds to maneuver, deploy countermeasures, or target the shooter. More importantly, passive infrared tracking enables the F-22 to detect and track enemy aircraft without ever powering up its own radar. Complete stealth, complete awareness, simultaneously. That combination is what adversaries have no reliable answer to. Fact 2. The upgrade makes the Raptor harder to see in ways radar alone cannot solve. Enemy air forces have known for years that they cannot reliably track the F-22 with radar, so they invested in passive infrared detection systems of their own. Both Russia and China have deployed these on their latest fighters and ground-based air defense networks, specifically as a workaround to American radar stealth. The F-22 modernization program addresses that directly. Test aircraft photographed near Edwards and Nellis Air Force bases have shown advanced low-observable material improvements, new coatings and surface treatments that look noticeably different from the matte gray finish on standard Raptors. The goal is to reduce the aircraft's detectability, not just to radar, but across multiple sensor spectrums, including infrared. The original F-22 coatings had a known operational weakness. They were maintenance intensive. The radar absorbent materials degraded under operational conditions, requiring significant upkeep to maintain performance. Every hour of flight translated into maintenance hours on the ground just to preserve that low observable profile. The new materials being developed take lessons directly from the F-35 program. More durable, more environmentally stable, and designed to provide consistent performance across a wider range of conditions. Critically, the improvements are also aimed at managing the heat signatures that infrared sensors hunt for. At the same time, the electronic warfare suite is being upgraded. The ALR-94 system, already one of the most capable airborne electronic warfare packages flying, is receiving new hardware and software improvements that enhance both threat geolocation and jamming effectiveness. Harder to detect by radar, harder to detect by infrared, and if something does pick you up, harder to keep tracking. That layered survivability approach is what makes the modernized F-22 genuinely difficult to counter. Fact 3. The Raptor can now reach out and kill things it couldn't before. The F-22 has always been an exceptional weapons platform, but there's a constraint baked into any stealth aircraft. Weapons have to be carried internally to preserve the low radar signature profile. That puts limits on range and the number of shots available. The AIM-26 Zero-Joint Advanced Tactical Missile is being integrated onto the modernized F-22, and it substantially changes those limits. The specific performance parameters remain classified, but the program's stated purpose is clear: provide a weapon capable of outranging current adversary long-range air-to-air missiles, particularly China's PL-15, while fitting within the F-22's internal weapon base and maintaining full stealth throughout. Recent long-range missile tests have demonstrated improved engagement envelopes beyond what previous F-22 weapons could achieve, and the AIM-260 is designed to extend that reach further still. The tactical picture this creates is significant. The F-22 detects an adversary formation passively, using infrared sensors, without revealing its position. It launches the AIM-260 from a range the enemy didn't expect to be in danger at. And by the time that missile is tracking toward its target, the F-22 is already repositioning or aggressing, still undetected. Beyond the missiles, the program is developing low-drag external fuel tanks with improved low-observable characteristics, specifically for extended Pacific operations. The distances involved in potential conflict scenarios in that theater are significant. Earlier external tank designs solved the range problem, but compromised the stealth advantage. These new designs are engineered to minimize that trade-off, giving the F-22 the fuel range to operate across those distances, while arriving with full combat capability intact. Fact 4. The cockpit has finally caught up with the aircraft's capability. This doesn't get the dramatic headlines, but it may be the most operationally significant change of all. F-22 pilots have lived with a real frustration for years. They were flying the world's most capable fighter with sensors that could track threats at extreme range and weapons that could engage beyond visual range. But target designation still required maneuvering the aircraft's nose toward the threat. In a complex, multi-threat engagement, that's a meaningful limitation. The Modernization program introduces a helmet-mounted display system for the F-22. With helmet cueing, the pilot can designate targets simply by looking at them, not by maneuvering, not by working through complex button sequences. Look at the threat, lock it up, engage. At the high angles of attack, the F-22 routinely achieves in combat maneuvering. This is transformative. The aircraft's agility advantage becomes directly translatable into weapons employment flexibility in a way it previously wasn't. The communication architecture is also being overhauled. The original F-22 had constrained two-way data sharing with other platforms, a genuine tactical limitation that affected how well it could coordinate with the larger strike package around it. The modernized F-22 receives full two-way Link 16 integration across all service branches and allied forces, making it a far more effective node in joint operations. And beyond current upgrades, the F-22 is being positioned for future manned-unmanned teaming roles. The architecture being built into these aircraft is designed to eventually allow F-22 pilots to coordinate with autonomous collaborative combat aircraft. One pilot in a future operational scenario may direct unmanned systems performing scouting, electronic warfare, or additional weapons carriage, multiplying the combat effect of a single manned platform considerably. Fact 5. This modernization buys time, and the timing is everything. This is the dimension most people miss when they focus on the individual hardware upgrades. The F-22 modernization program isn't just about making the Raptor more lethal. It's about closing a strategic window before an adversary decides to try and exploit it. Here's the gap. The Next Generation Air Dominance program is moving forward, with Boeing awarded the contract for the Next Generation manned fighter in March 2025. First flight is not expected until 2028, and meaningful operational numbers reaching combat squadrons will take us well into the 2030s. For several years, America's air superiority rests substantially on 143 combat-coded F-22s that were aging in place on their original systems. China understands this timeline. Their J-20 production is accelerating. They don't need to match the F-22 aircraft for aircraft in capability. They need enough numbers that the arithmetic starts working in their favor. A fleet of F-22s with 2005-era sensors is a meaningfully different strategic proposition than the same fleet with passive infrared integration, improved low-observable coatings, extended range weapons, and future teaming capability. The $7.8 billion investment, projected to climb toward $11 billion through 2031, is in part a deterrence message. It signals that the capability gap between American air power and any credible challenger is not narrowing on a convenient timeline. It is being actively maintained. There's also a deeper programmatic logic here that rarely gets discussed openly. Technologies being proven on the modernized F-22 feed directly into the Next Generation Air Dominance program. The passive infrared architecture, the advanced low-observable materials, the manned-unmanned teaming protocols. The F-22 fleet is functioning as an operational testbed for systems that will define the next generation of air combat, proving concepts in real conditions rather than in simulation. And the oldest F-22 variants, previously limited to training roles, are now being brought up to combat-relevant standards under this program. That adds roughly 30 airframes to the combat-available fleet, taking the usable force from 143 toward approximately 178 fully modernized aircraft with capabilities that simply didn't exist when the production line closed in 2012. The F-22 Raptor earned its reputation over 20 years of operational service. No aircraft ever exported. A combat record that speaks for itself. A platform that adversaries have spent 20 years trying to build an answer to, and haven't. The F-22 Modernization program doesn't rest on that reputation. It builds on it, with passive sensors that detect threats while revealing nothing. Low observable improvements that defeat both radar and infrared detection. Weapons that reach beyond what adversaries currently expect. A cockpit that finally gives pilots full access to what the airframe can do, and an architecture that positions the F-22 for the future of manned-unmanned operations. 20 years in, the most capable air superiority fighter ever built is getting better. That's not hype, that's the program. If you want analysis like this, grounded in what's actually documented, not just what sounds impressive, subscribe to Dogfight Docs. Drop a comment on which of these 5 upgrades you think changes the tactical picture most. I'll see you in the next one.